Hey guys. Alright, Bridge to College, this is you. I'm Mr. Mailhot. Let's do a problem. Okay, this comes from task 15, unit 1, lesson 1. We did these ones kind of together. You worked on them in class. I said I'll post a video for this one for your homework. Let's go through it. B was kind of weird, and it even took me a little while to think through it. I think part of the design of the problem is what's making it confusing. So let's talk about it. The main idea is still asking if things are equivalent. So let's just look through our three options. I know it says use the figure below. We'll do that in a second. Okay, x plus 1. We can't simplify that at all. It's just x plus 1. Same with 3x plus 1. Now hopefully you notice that these two are not equivalent, right? X plus something and 3 times x plus something, not going to be the same answer. There may be special cases, but won't be the same. This last one. Okay, most of us are pretty good with this distributive property to recognize this is 3x plus 3. But let's think of it another way, and I think this will help us show it on this diagram here. This is also saying, if we take the original one, the 3 times x plus 1, that's saying 3 groups of x plus 1. Yes, it's also the same thing as 3x times, or 3x plus 3, but it also means in words, it means 3 groups of x plus 1. So let's go through this. Let's do a little color coding. Here we go. Blue. Let's have blue be this first one. X plus 1. Okay. I think this is where I'm a little confused. I think we're supposed to draw on this one and use this one as reference. So check it out. Here's an x plus 1. Maybe it'll help if I write it up here. This represents a 1, an x, a 1, an x, a 1. I'm getting that from the line right below. I don't know why they gave us both, but whatever. X plus 1, well, how would we represent that length? Well, that would be an x plus a 1. Let's section them off, because there's 2 sections. X and 1. All right. 3x plus 1. I know it says just to compare these two, but we'll look at all of them. 3x plus 1. Well, this is where it gets a little weird. There's an x. There's an x. There's another x. I don't know why this is what I'm saying. It's a little weird. Plus 1. So 3x, 1, 2, 3, plus 1. Okay. Now, if we were able to cinch these segments together, you'd see that the pink one is longer than the blue one, which would make sense because there's 3 times as many x's. Let's do the last one. 3 times x plus 1. This is where this 3 groups of x plus 1 comes into handy. Here's a group of x plus 1. An x and a 1. Here's a group of an x plus 1. An x and a 1. And here's another group of an x and a 1. X and 1. So the way they have it drawn here in this visual representation, 3 groups of x plus 1s, 1 group, 2 groups, 3 groups, for sure is bigger than 3x plus 1. I mean, the green takes up the whole number line, the whole diagram line, and the pink only has a couple little sections. We knew that already because of distributive property that they wouldn't be the same up here, and we could plug in numbers and prove that they didn't work, but visually, that's a real challenge to go from numbers to a visual representation, but visually, you can also prove this whole green thing, 3 groups of x plus 1, is not the same as 3 x's plus a 1. All right, guys, I hope that cleaned it up a little bit. Remember, this will be due when we have our next quiz. Good luck. See you next time.